I'll reiterate, you may use any of the equations in the problem that involve both x and y. And I've simply chosen the first one. Well, then that means that we'll take 4 times the x value. Our x value is 3, plus y equals 2. So we'll fill in 3 for the x, and then work it out. 4 times 3 is 12, so we get 12 plus y is 2. Then we subtract 12 from both sides, or add negative 12. 12 plus y subtract 12 equals 2 subtract 12. On the left, the 12's cancel. On the right, we get 2 subtract 12, which is negative 10. And so our y value is negative 10. That means that the answer is the ordered pair 3, negative 10. Notice that, as always, we write the ordered pair in parentheses, 3, negative 10. Now, in back substitution, we had a lot of freedom about which equations we could choose to work with. However, in the check always is in the original. And so we go back and use the original system for the check. Remember that we must check our ordered pair, 3, negative 10, in both of the original equations. So let's go through the check. Our first equation, 4x plus y equals 2. That means we'll fill in the x number and the y number. 4 times the x number, which is 3, plus the y number, which is negative 10. And on the right-hand side of the bar, simply 2. 4 times 3 is 12, so we get 12 plus negative 10 equals 2. And 12 plus negative 10 is 2. And so we get 2 equals 2, which is correct. Now we check in the second equation. In the second equation, we have 3x plus y equals negative 1. And so we'll fill in the x value and the y value. 3 times the x value is 3, plus the y value, which is negative 10. On the right-hand side, we have negative 1. Now we simplify on the left and get 9 plus negative 10 equals negative 1, which tells us negative 1 equals negative 1, and of course that checks as well. For our next example, we have 3x subtract 7y equals 13, and 6x plus 5y equals 7. We can choose to multiply by any numbers we prefer so that the coefficients of one of the letters are opposites. It's like finding a common denominator, remember? A common denominator for 3 and 6 would be 6. A common denominator for 7 and 5 would be 35. I'm going to go with the easier version, which is the 6 for the coefficients of x. I'll make one of these be positive and the other be negative. Since one of the equations already has the coefficient I want, the second equation with the coefficient of 6, I will simply multiply by 1. That is, leave the second equation unchanged, just for laziness. The first equation has a coefficient of 3. I would like a coefficient of negative 6, so that when I add it to 6x, these will cancel. That means I must multiply the first equation by negative 2. And so we multiply negative 2 times the first equation, and we get negative 6x plus 14y equals negative 26. For the next equation, 1 times the equation is simply as it is, copied. Now we're ready to add the two equations. When we add negative 6x and 6x, they cancel. 14y and 5y will give us 19y, and negative 26 plus 7 will give us negative 19. 19y equals negative 19. We solve by dividing by the coefficient of y, which is 19. Dividing both sides by 19, we get y is equal to negative 1. Now we have found the y value, and I must go back to find the x value. For the x value, I can choose any of the equations for my back substitution that involves both x and y. Notice that we have 6x plus 5y equals 7, negative 6x plus 14y equals negative 26. Here's the 6x plus 5y equals 7 again, and 3x minus 7y equals 13. I can choose any of those that I prefer. The one I have chosen is 6x plus 5y equals 7, and that's purely my own preference. You may choose any of them that you wish when you're doing these problems. So I'm going to use the 6x plus 5y equals 7 for my back substitution equation. This means that we'll fill in the negative 1 for y. So we have 6x plus 5 times the y number, which is negative 1, equals 7. Then it's just a matter of working this equation. Simplifying on the left, we get 6x subtract 5, or 6x add negative 5 if you prefer. Now to solve for x, I must first eliminate the 5 that's subtracted. I'll add 5. 6x subtract 5 add 5 equals 7 add 5. On the left, the 5's cancel, leaving me with 6x. On the right, 7 plus 5 gives me 12. Dividing by 6 gives me x equals 2. And so this means that the ordered pair solution is the x is 2, the y is negative 1, and so we write the ordered pair 2, negative 1. 2, negative 1 for the final answer. The only thing left is to check. Remember, we're checking in the original, and so I recopy the original equations. First, the 3x subtract 7y equals 13. On the left-hand side, we have 3 times the x number, subtract 7 times the y number. On the right-hand side, just 13. The x number is 2. The y number is negative 1. And so we get 6 plus 7 on the left, 13 on the right, and of course 13 and 13 are the same. So this one checks. For the other equation, 6x plus 5y equals 7. We have 6 times the x expression plus 5 times the y expression equals 7. The x expression is 2. The y expression is negative 1. Simplifying on the left-hand side, we get 12 plus negative 5. On the right-hand side, we have 7. 12 plus negative 5, or 12 subtract 5, is 7. We get 7 equals 7, which is correct.